A very good afternoon, class. So, as you all know, we have already started with the fourth part of our syllabus, that is lesson number 7, assignment problems. And we have already finished 3 lessons of Maths 2. I hope you all are practicing and revising the sums which we have finished. So, class, we were learning how to solve the assignment sums based on Hungarian method. Now, yesterday we finished all the minimization problems related to 5 types, that is balanced, unbalanced, restricted, alternate solution, and also when the number of lines are not equal to the number of rows and columns. The same 5 pattern will be revising again, but this time the problems will be on maximization. So today onwards class, we'll be targeting sums which are based on maximization objectives. So today our focus will be on 2 types of sums. Basically balanced and minimization problems, balanced and maximization problems, and unbalanced but maximization problems. So let us start with the solution. Yes, but before that, this technique I had already taught you all in minimization as well. So whenever you all solve the sum by Hungarian method, be it minimize or maximize, you have to do some basic common check before starting the sums. That is, check whether rows are equal to columns. So if they are equal, it will be called as a balanced problem. And if they are not equal, you know class what to do. Do you remember? Correct. You add a dummy row or a dummy column. Similarly, you have to pay attention to the very important part, that is, what is the objective function? That is either to minimize or maximize. If it is minimization, the procedure is yet very simple. You start with the first step, that is converting in row minimization. Then you do the second step, column minimization, and so on. But what if the objective function is maximization? So related to this particular question, pay attention for the further sums which will be coming in your slides. So here comes example of category 2, that is balanced and maximization. 3 different aeroplanes are to be assigned with a view to maximize the profit. Profit matrix in lakhs of rupees is as follows. So this is a particular matrix which is given to you. How should the cargo consignments be assigned to the aeroplanes to maximize the profit? So class, this is the sum which I come across. Now the first step will be to do the basic check. So in this case, the number of rows are 3 and the columns are also 3. So I can say that here the rows are equal to columns. Second, my objective function here is to maximize the profit. So how to start the sum when the problem is based on maximization objective? So the first step class basically changes to like this. You have to convert this matrix into a minimized matrix. Now, how will you convert this into a minimized matrix? The step is very simple. From the entire matrix, pick up the biggest number in the matrix. In this case, the biggest number is 5. You have to subtract all the numbers from the biggest number. That is, I'll be subtracting all the remaining numbers from the number 5. So the matrix which I'll be getting will look like this. That is 5 minus 1 gives me 4, 5 minus 4 gives me 1, 5 minus 5 gives me a 0. Similarly, 5 minus 2, 5 minus 3, 5 minus 3, 5 minus 3, 5 minus 1 and 5 minus 2 gives me the remaining numbers. So class, this is your very first step. So whenever you come across maximization problems, always convert the matrix into a minimized matrix. Now the matrix is ready to be solved by Hungarian method, which is none other than starting with row minimization. So the further procedure is the same as I've taught you all in the maximization problems. Sorry, in the minimization problems before. So here we'll pick up the minimum row elements from each particular row like this. So in A1, the minimum number is 0. In A2, it is 2 and 2. In A3, it is single number 2. So my next step will be converting in row minimization. So the matrix after subtracting will look like this. After row minimization, you all know class what is the next step? Converting in column minimization. So I'll be picking up each minimum number from each particular column. So in C1, C2 and C3, all the minimum numbers are 0. So I will get the same matrix as the row minimization because anything subtracted from 0 gives you the same number. Now before I move forward and draw the lines, I should check that in each row and each particular column there is a single 0, at least one 0. So the condition is satisfied. So moving forward with the next step, drawing the required lines. As I told you class, always start with rows first. So can you tell me which number of rows can be covered by minimum number of lines? Correct. It is the second row, A2. After that, in column you see a single 0. Here also you see a single 0. In the same way, in the rows also if you see, there's a single 0 each. So either we go column wise or row wise, we have to draw two lines. So I will take the two particular columns. Now, what's the next step? As the number of lines are equal to the rows and columns, we can allocate the jobs as below. Do you remember class? What was the procedure for allocating the jobs? You should start with that row first which has got a single 0. So in our case, it is row A1 which has got a single 0. So I will put that 0 in a box. And simultaneously in that particular column, I will cancel the extra 0. Coming to A2, 1 0 is already cancelled. Remaining 1 0, I can put it in a box. Coming to row A3, again there's a single 0. So I will put that 0 in the box. So class, are the number of allocations equal to the number of rows and columns? Correct. That means we have got all the allocations. So for aeroplane A1, the cargo assigned is C3. For aeroplane A2, the cargo assigned is C2. And for aeroplane A3, the cargo assigned is C1. This was your original question class. Compare it with your final answer of the allocation like this. So in place of this 0, you had 5. In place of this 0, you had the number 3. And in place of this 0, you had number 3. We had to find the total maximum profit. So the answer is 5 plus 3 plus 3 rupees 11 lakhs. So I hope the first type of problem, that is balance and maximization, is clear. Pay attention to the next problem as well. This sum is from your exercise 7.1. Sum number 5. Giving you all 2 minutes to read the question. So I hope you all have read the question. So class, do the basic check first. Are the number of rows and columns equal? Yes, they are. What about the objective function? The objective function is to check which particular assignment of the salesman to which particular district which will yield maximum profit. So class, the objective function is to maximize the profit. So how to start the sum? Step number 1, converting in minimized matrix. How to convert the matrix into a minimum one? Do you remember? The biggest number in the matrix is 16. So you have to subtract all the numbers from 16 and you will get a matrix like this. After converting it into a minimized matrix, what's the next step? Correct. You have to convert it in row minimization. So underline all the minimum elements in each particular row A, B, C, D like this. After subtracting, you get a matrix like this. Now after this, you have to complete the sum as an assignment. I hope you all know how to continue the sum. Convert it in column minimization. Then before drawing the lines, check whether each row and each column is having at least one zero. If the number of lines are equal to the number of rows and columns, you can allocate the jobs and then find the final answer for this particular problem. So moving on to the next category, sum, unbalanced and maximization. Observe this question, class. The sum is from your miscellaneous exercise, sum number 4. I hope you all have observed the sum. What is your, you have to do the basic check first. Are the number of rows and number of columns equal? No, they are not. So what you will do first? Correct. You will make it a balanced problem. And how will you do that? You will add a dummy column because P, Q, R, S, these are the 4 columns. We require one more column. That is why we'll name it as column T. And all the elements of that particular column will be 0. Okay. So find out the assignment of managers to cities in order to maximize the sales. The objective function over here is nothing but maximization. So maximization involves another step. Do you all remember, class? What was it? Correct. You will change it into a minimized matrix. So after adding a dummy column T, your matrix will look like this, where all the elements are 0. Moving on to the next step, that is converting it into a minimized matrix. That is, the maximum number in the matrix is 39. So you will subtract all the numbers from 39 and you will get a matrix like this. So remember, class, whenever you subtract the numbers, you will get it like this. And 39 minus 39 gives you a 0. Also, 39 minus 0 gives you 39. So that is why the entire last column has changed from 0 to 39. What is the next step? Correct. You have to convert it into row minimization. So these are all the minimum numbers from each particular rows. You will subtract them from their respective elements in that row and get a matrix like this. After that, you will find out each minimum n number from particular column like this and subtract them from their respective columns P, Q, R, S and T. So you will get a column matrix like this. Now what should be the next step, class? Draw the lines. But for drawing the lines, check whether each row and each column is having at least a single 0 in it. The condition is satisfied. So now we can draw the required lines. So how to draw the lines, class? Check in the row wise which row has got the maximum number of zeros. Correct. It is row number 1, row number 2, row number 4 and row number 5. Now you can check column wise. So there's left only 1 0. So you can draw a line like this. So number of lines are equal to the number of rows and columns. So we can start with allocation of the jobs. Now tell me, class, the first box will be assigned to which particular row? Is it the first? Is it the fourth? Or is it the fifth? The first box will go in row number 3, as row number 3 has got a single zero. What about the other 4 zeros above and below it? They will get cancelled like this. Now tell me class, next 0 will be assigned where? Correct. You cannot go backwards. So first you have to go forward. So the next box will be assigned to column number 4. After that, column number 5. Sorry, row number 4 and row number 5. Sorry for my mistake. Now all the rows are finished. Now go column wise. So column P, Q and R are already having one job assigned. What about column number S? There is a single zero, so we'll give a box over there. And finally, the last box will go to column number T. What is your observation, class? Has each particular worker received one particular job? Correct. So our assignment table will look like this. Each manager is assigned each particular city. So 1 is given S, 2 is given T, 3 is given Q, 4 is given P, and 5 is given R. This is your final answer, class. How will you compare? This was your original matrix of the question, including a dummy. And this was the final answer which you got. So compare the boxes and see what will be the total maximum sales. Here in S, you have got 35. Here, this was a dummy, so the number is 0. Here, the number is 39. Here, the number is 36. And in this particular box, number is 35. So the total maximization of sales is equal to 35 plus 0 plus 39 plus 36 plus 35, which is 145 tons per month. So I hope, class, you all have followed the concept of balanced and unbalanced maximization problems. Next week, we'll be continuing sums related to the next 3 types, that is restricted, alternate solution, and when your number of lines are not equal to the number of rows and columns. Till then, keep practicing, keep studying, and keep learning. If any doubts, please let me know on my WhatsApp number. And I'll see to it that in the next video, I can clear all the doubts that you'll ask. Thank you so much, class, for listening to me. Till then, stay safe, keep healthy. Thank you so much.